Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to build an intelligent AI Telegram bot that is going to be able to recognize animals and vehicles inside of images that we send to it. So let us get right into it. Now, before we get into the actual coding, I want to show you what this bot is going to look like in the end. I have it on my phone now. I have Telegram opened, and I can now start the conversation by clicking on Start, and then it's going to say, "Welcome to the Neural 9 Telegram bot." I can do something like "Hi," and it says, "Send a photo." Okay. The first thing we're going to do here is we're going to call the /train command. So /train, this is a function that I have implemented in the bot. And then it's going to say, once it's sent, neural 9 image classification, we are training the neural network, please wait. Now, at this point in time, my computer, my laptop, right now, the bot is running on my system, is starting to train the neural network based on training data. Once this is done, I'm going to get a message that this is done, and then I can send images of horses, planes, cars, trucks, whatever, and the Telegram bot is going to give me a response with what I see in this image is a truck, what I see in this image is a plane, what I see in this image is a deer or a horse or whatever. Like, we have 10 things that it can classify, and now we're going to skip to the part where the bot is already trained here, or the model is already trained. Alright, so the model is now done with training, and we can try to send a picture. Let's go and send a picture of a car. There you go, and it says, in this image I see a car. So this one is correct. Let's go with a deer. And it says, in this image I see a deer. And let's go with this one of a horse. In this image I see a horse. Now, it's not always going to be 100% accurate. By the way, those are all pictures that the model has never seen before, so they're not part of the training data set. But as you can see, those three at least were classified correctly. Alright, so the first thing we're going to do here is we're going to go to Telegram, to the app, or to webtelegram.org, and we're going to look for the bot father. And once we have the bot father, we're going to start a conversation with the bot father, and we're going to click on new bot, or we're going to type /new bot down here. This is basically just going to start the process of creating a new bot. It's going to ask you for the name, you provide the name. For an identifier, you provide the identifier, and then basically it gives you the API key, and that's it. Then we proceed to the Python code. I'm not going to do this here again because I already have a bot created. It's not complex. Just type /new bot, and it's going to give you all the instructions. The important thing is that you copy the token, the API key. And if you really want to see the step by step on how to do this, which is not really difficult, you can check out my video Telegram bot in Python, where I go through the very basics of creating a very simple Telegram bot in Python. This video is a little bit more advanced. It's like a second part where we make it intelligent using a neural network. So basically just /new bot, creating a bot, and then copying the API key. That's the first step. Then we go to PyCharm, and the first thing we want to do is we want to get the token into the script somehow. So if you're not recording like I'm doing, you can just type token equals and then a clear text string where you just paste the token. In my case, I'm going to load it from a file so I don't have to show it to the viewers. So with open token.txt in reading mode SF, and then token equals f.read, basically. Now, we're going to need a bunch of libraries for today's video, and the most important one is, of course, the Telegram library. We're going to install it, and we also need OpenCV, we need NumPy, and we need TensorFlow. And we're also going to need the I/O module, but we're going to talk about that in, or when it's necessary. So first of all, we're going to start CMD, and we're going to install the necessary modules. We're going to start with TensorFlow, pip install TensorFlow, like that, then pip install NumPy, then pip install opencv-python, and of course the Telegram library, it's called python-telegram-bot, like that. This is what you need to install. Those are the libraries, and now we can go ahead and import them. So we're going to say from telegram.ext import everything, then from IO import bytes.io. We're going to talk about why this is important. Then import CV2, import NumPy SNP, and import TensorFlow STF. All right. So let's start first of all with the basic structure of the bot and then add the the rest later on. So first of all, we're going to define the basic functions that we already know. So def start, the start function, what happens when we actually start the conversation with our bot. So we're just going to pass update and context here again, like in the last video. When I say again, I'm referring to the last video. I recommend you to watch the last video if you haven't watched it yet. So the last Telegram bot video. And basically all we did here was just saying update.message.reply text and then welcome or something. You can design the messages however you want. You can say welcome to the classifier, welcome to whatever. I'm just gonna say welcome here. Oh, I closed the script. Then we can also define a help function if we want to. So we're going to say update context, and we're just going to have a message that says multi-line string, there you go, / start starts conversation / help shows this message, and then / trains neural network, which is going to be another function down here. It's going to be the train function, update context as well. But we're going to pass for now because we don't have the model yet. And then we're going to have a basic handle message and a basic handle photo function. So the handle message function is just going to be what happens if we just send a text message. We're going to call this handle message, update context again, and we're just going to say update message reply text. Please train the model and send a picture. There you go. And the important function now is the handle photo function. Again, with update and context. And we're going to pass this for now as well. So let's first complete the steps that we already know from the last video. We're going to say updater equals updater with a capital U from the Telegram module. We're going to pass the token here and use context equals true. And then the dispatcher is going to be updater.dispatcher. Not .dispatch, .dispatcher as an object here. And now we can add the handlers that we already have. So we're going to say dp.add command handler, or actually add handler. And we're going to add a command handler for the command start. And if we see the command start, we're just going to call the start function. Going to do the same thing with help. And with train. There you go. And now we're going to add a message handler, or actually two message handlers, but they're going to have different filters. So we're going to say dp.addHandler message handler. This is what we already had in the beginner video, where we basically just say, okay, filters.text. Whenever text is coming, it's going to be filtered for this message handler, and the handler itself is going to be handle message, like that. And now we're going to add a second message handler, which is going to not filter for text, it's going to filter for photos. So filters.photo, and it's going to be handle photo. All right, and in the end, of course, updater.start polling and updater.idle. There you go. So what we need to do now is we need to have a basic neural network model already ready, and we need to be able to train it by calling the train command. And then when we send a photo, we want to process that photo, we want to scale it down, we want to feed it into the neural network, get a prediction, formulate an answer or a prediction response, and then send this to the user. Now let's start with the model itself. We're going to build a convolutional neural network to classify the images. And as a training data set, we're going to use the Cipher or Cipher. I'm not sure how it's pronounced. It's CIFAR. This 10 data set, so Cipher 10. We're going to use that to train our model, and it's going to have 10 classes, 10 objects it can classify, 10 image types it can classify. So let's start by loading the training and testing data. We're going to say xtrain and ytrain and xtest and ytest is going to be tf keras dot datasets dot cifar10 dot load data, like that. And then we're going to normalize this. So we're going to say xtrain and xtest is going to be xtrain divided by 255 and xtest divided by 255, so that we have all the values between 0 and 1. And now we also want to have a list with the class names, because in the end, the neural network is going to produce a number, a numerical output, and we want to map that to a class name. So we're going to say class names is, and this is the right order. You need to have that order. The first one is plane. The second one is car. The third one is bird. Then we have cat. We have deer. We have dog. We have frog. We have horse. We have ship. And we have truck. So as you can see, vehicles and animals. That's basically it. Now we can start with the actual neural network. So let's go ahead and say the model is going to be a basic sequential model. So tf keras dot models dot sequential. Very simple sequential model. And then we're going to start by adding some layers. The first layer is going to be a two-dimensional convolutional layer. So we're going to pass tf.keras.layers and then conv to d, like that. And we're going to pass the filters. We're going to have 32 here, and then the kernel size is going to be 3 by 3. The activation function is going to be a rectified linear unit, so ReLU. And the input shape is going to be 32 times 32 with 3 channels. This is because the pictures, the images in the training data set have 32 by 32 pixels, and they're RGB, so they have 3 channels. Now what's the problem here? Oh, we need to say that is the input shape. There you go. So that's the first convolutional layer. I'm not going to go into the theory of convolutional neural networks here, because that would deserve a video on its own. So if you want to know, okay, how does a convolutional neural network work? How does a max pooling layer work, and so on? Let me know in the comment section down below that you're interested in theoretical videos on neural networks, and then I may make some tutorials in the future. After the convolutional 2D layer, we're going to add a max pooling layer. So tf keras.layers.maxpooling2d, and we're going to pass a pool size of 2 and 2. Then we're going to add another convolutional layer, so model add tf keras.layers.conv2d, and this time we're going to have 64 filters, and the kernel size is going to be 3 again, and the activation function is going to be rectified linear unit once more. And now we can actually just go ahead and copy this. We're going to have another max pooling layer. We're going to have another convolutional 2D layer. And after this one, after the third convolutional layer, we're going to flatten the results. We're going to say model.add a flatten layer. And we don't have to specify anything here. And in the end, we're going to have one more dense layer for complexity, and then the final output layer. So we're going to say model.add tf.keras.layers.dense with 100, or actually, let's go with 64 units, and the activation function is going to be rectify linear unit. And in the end, the output layer is going to have the softmax activation. So we're going to say layers dense again, and we're going to have 10 outputs because we have 10 possible classes, and the activation function is going to be softmax. For those of you who don't know what softmax does, softmax is basically just producing a result where if you add up all the individual neuron activations, you're going to get 1. So they all add up to 100%, which basically means that each neuron indicates how likely it is the right classification. So for example, if we have a picture of a dog, an obvious picture of a dog, the neuron that is responsible for the dog is going to be very highly activated, something close to 1, 0.9 something, and all the others are going to have a pretty low activation if the model works properly. So this is basically giving us the likelihood for each neuron to be the correct solution. All right, so this is the neural network itself, but it's not trained, it's not even compiled yet, and this is what's going to happen in the train function. Once we call the train function, we want to say to the user that now we are training the model. Model is being trained. Then we're going to, first of all, compile the model. So we're going to say model.compile. And we're going to have the atom optimizer for this. We're going to have the sparse categorical cross entropy as a loss function. And the metric that we're interested in, metrics equals, is going to be accuracy. There you go. And after that, do we have a mistake here? Oh, I still have a pass, right? Let's remove the pass. There you go. Then model.fit, and we're going to fit on the training data with 10 epochs. This is going to be necessary for this one. And the validation data we're going to provide here is going to be x-test and y-test. So let me just see what the problem is here. We don't have a problem. Okay. So the model is being fit, and then we can save it, model.save, and we're going to save it as, I don't know, cipher classifier.model. And once this is done, we're just going to tell the user that done, you can now send a photo. All right, so that's almost all of it. The only thing that's left now is to get the actual images from the user and then feed them into the neural network and get a response, get a prediction, and then send a response to the user. So first of all, through this filters.photo, we're only going to get photo messages to that function. So whenever we get something in that function, it's going to be an image. And because of that, we can just get this image from saying file equals context.bot. So the context is this parameter here. We have use context equals true, so that works. Context bot get file, and we're getting the file update message photo. We're going to get a photo from the message, and we'll just get the last one if we have multiple of those, and we're going to get the file ID. So we're going to actually get the whole file as a byte stream, as a byte array. So what we're going to do here is we're going to say f equals bytes IO, which is why we had this import in the beginning, this from IO import bytes IO. And inside of that, we pass file.download as byte array, like that. And then we get the bytes themselves. So file bytes is going to be np as array. It's a little bit technical here, right? Byte array of f.read, and the data type of this whole thing is np.uint 8 bytes. So unsigned integer 8 bytes. Those are the bytes, and we can now actually go ahead from those bytes and load the image using OpenCV. So this is the, you could say, pre-processing of the image, or actually not pre-processing, this is the getting of the image. This is the way we actually load the image into the script. And now we can go ahead and actually get the image object. So cv2.imDecode, we're going to decode the image from the byte stream. So we pass the file bytes here, we decode from the file bytes. cv2.imRead underscore color is going to be the flag that we pass here. And now that we have that, we basically have the image in our script. So the first thing we want to do is we want to swap BGR to RGB, because by default, OpenCV uses the BGR color scheme, but the image has RGB. So what we're going to do is we're going to say cv2.convert color of the image, cv2.color RGB to BGR. There you go. And what we also need to do is we need to resize the image. Now, the best thing would be if we just pass images with the right resolution, but sometimes we're going to pass pretty high resolution images, as we did in the beginning in the demonstration. So in this case, we want to resize the images to be 32 times 32 pixels. And for this, we say image equals cv2.resize, and we resize the image. We pass 32, 32 here as a tuple, and the interpolation is going to be cv2.interarea. There you go. So we end up with 32 by 32 pixel image. And now we can go ahead and say prediction equals model.predict. And we need to pass the right format. First of all, we need to pass an NP array and a list of the image. However, the image, as we saw here, we had divided by 255 as a training data. And because of that, we want to do the same with the actual prediction, because otherwise we're going to get inaccurate results. So divided by 255 here. And this is how we pass it. This is then going to be the prediction. And remember, the prediction is the activation of all the neurons. So what we want to have is we want to have the neuron with the highest activation. In order to get that, we need to apply the numpy argmax function onto the prediction to get the index of the highest value. So what we're going to do is we're going to say update reply text f string, and we're going to say in this image I see, and then A or N, whatever. And what we're going to pass here is the argmax. So we're going to say NP argmax of the prediction. Now, the problem with that is that this is going to give us the index of the neuron with the highest activation. So what we want to do is we want to get the class name at that index. So class names at the index of the highest activation. That is it. Or do we have a problem here? No, we don't have a problem here, right? Class names, NP argmax. I don't think we should have a problem here. All right, so that is basically it. Let's review the code real quick. We have a model up here. We have this convolutional neural network structure. We load the training data. We normalize it by dividing by 255 because the RGB values go from 0 to 255. We have the class names. We have the token here. We have a basic start help function, a basic handle message function. Then we have this train function that actually trains the model by calling compile, fit, and then saving the model, just in case we want to load it later on. And then we have this handle photo function where we basically get the image from the message. We convert it to a byte stream. We decode the byte stream. We convert the color scheme from RGB to BGR, or you could also say from BGR to RGB. We resize it, and then we predict the actual class. And in the end, we say, okay, in this image, I see a class names NP argmax prediction. NP argmax basically just gives us the highest activation index. And at this index, we also have a class name, which is going to be the proper class name. All right, so that's it. We need to run it, but of course, this is going to take a long time. Let's just see if we have any mistakes here. If I run this, this should work. And then we're going to skip through the part where the model is already trained. Or actually, we need to train it first. So actually, let's go to Telegram web, because we need to go to the neural bot here. And we need to actually delete all that. Or actually not delete it. We can just go ahead and train the model again, because if we don't give the /train command, we're not going to see any training happening. So we can go to PyCharm. You can see nothing is happening. But if I say /train, then you can see model is being trained and the training started here in the script as well. And now we're going to skip to the part where the training is done already. All right, so the training is now finished. We can look at PyCharm and see that 10 epochs are done, and we can now go ahead. It says done. You can now send a photo. We can go ahead and send a photo. First of all, a truck. Let's see if it classifies that one correctly. Let's send it. And it says, in this image, I see a truck. So this is correct. Let's go ahead and try the second one, which is a bird. Send. In this image, I see a bird, so this works. Let's go with a frog. Now, those are all pretty obvious pictures, obviously. I can see a frog, and last but not least, I have a plane, which is a little bit less obvious in my opinion, so I'm not sure if it's going to classify it correctly, but it should be able to do that. No, it sees a cat. Okay, so probably because it only sees the shadow of a plane, this one is a little bit more tricky, so you can see the model is not perfect, but if you have an obvious image of a frog or a bird or a cat or a plane or whatever, a truck, car, it works. And it can even distinguish a deer and a horse, which for a computer could seem quite similar actually. So it works decently. But this is how you build an intelligent image classifying Telegram bot. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.